So in order to go from rectangular x comma y to polar coordinate r theta, we have to do the following. First, we have to find r. So r squared is equal to negative 3 squared plus quantity 3 root 3 squared. So to find r, we use Pythagorean theorem. I like to draw a right triangle. R squared equals negative 3 squared plus 3 root 3 squared. So then we take square root, we get our value of 6. It's the hypotenuse. It's the distance from the dot to the origin. So the second part, that's the hardest thing to do, is to find theta. So what we do is we say theta is inverse tan of y over x. So we use our ordered pair, we insert our y over x. We end up getting theta is inverse tan of negative root 3. Remember, we always look at tan in first quadrant and then we reflect. So in the first quadrant, tan root 3 is at 60 degrees. So what I like to do is I say to go to the y-axis, that's a remaining 30. If I then reflect it into second quadrant, that's another 30 degrees from 90. So 90 plus the 30 gets us 120 for theta. Now that we have r and we have theta, we then can write our ordered pair, r theta. So r is 6 and theta is 120 degrees. So that's our final answer. Okay, I'm going to hop around. I'm just going to show you a few of each. So now E, we have our ordered pair written in rectangular form. To go to polar form, we first again find r. So r is going to be the hypotenuse, the distance from the center to that point. Use Pythagorean theorem, you get 5 root 2. So I inserted that value up here. Then the hardest part is finding theta. Remember, theta is inverse tan y over x. So I put the y value on top, x value on bottom. We have inverse tan of negative 1. If you have some kind of ratio where it's either 1, root 3, or root 3 over 3, whether it's positive or negative, you know that you're going to work with your unit circle and not your calculator. So in first quadrant, we know that at 45 degrees, tan is 1. Therefore, we are going to reflect across horizontally 45 degrees to end up at our dot. Now, if we know that our theta is in the fourth quadrant, the value for theta has to be between 270 and 360. So if we spin around, we know that we're at 270 plus this remaining 45. That gets us to our dot. And 270 plus 45 gives us a theta of 315. So up here, we have our polar coordinate, 5 root 2, comma, 315 degrees. Remember, you can write your theta in terms of degrees or radians. Okay, so remember, to go from polar to rectangular, it's actually a little easier. You just need to remember that x is equal to r cos theta. So we plug in. We know that r is 6. We know that it's cos, and theta is 120 degrees. Now, to find cos at 120 degrees, you need to think about reflections. I always work with first quadrant, and then I reflect. Now, I know 120 degrees is in second quadrant because it's between 90 and 180. I know that 30 more than 90 gets me to 120. Therefore, I know if I reflect this little section into first quadrant, this little piece is 30, which remaining is 60. Therefore, I want to look at the ordered pair at 60 degrees, and then I will just reflect. So at 60 degrees, we have cos is 1/2, sine is root 3 over 2. If I reflect that ordered pair into the second quadrant, we get negative 1/2, comma, root 3 over 2. Therefore, cos is negative 1/2 in the second quadrant. And then 6 times negative half gets us negative 3. Similarly, for sine, we know that sine, y goes with sine. So y equals r sine theta. So we plug in 6 and 120. We already wrote that ordered pair in second quadrant is for 120, it's negative 1/2, comma, root 3 over 2. So the sine at 120 is root 3 over 2. So sine at 120 is root 3 over 2. When multiplied by 6, or 6 over 1, we simplify and we get 3 root 3. And here's our ordered pair. Remember, again, when we're on the unit circle, we cannot use decimals.